Hello, and welcome to our 6th instructional video on how to plan UAS flight operations. This series of videos is brought to you by AmericaView, in partnership with the College of Natural Resources and Environment at Virginia Tech, the Virginia Cooperative Extension, and Geoted UAS. My name is Daniel Cross, and I will continue to be your guide. In this video, we will go over a basic pre-flight briefing. There are specific pieces of information that Part 107 requires us to know before each flight, but it's a good practice even if you're flying as a hobbyist. Part 107 legally requires that before each flight, we are aware of any information that may affect the safety of the flight. We do this by using official sources to get notices to airmen, or NOTAMs, as well as a weather briefing. To make sure that I have the most current information, it's a good idea to get our briefings as close to flight time as possible. Let's start with NOTAMs. NOTAMs are the way the FAA ensures pilots of all types get information that is not available elsewhere in a timely manner. This information includes, but is not limited to, airport closures, military exercises, temporary obstacles near airfields, and changes to airspace such as temporary flight restrictions, or TFRs. For UAS operators, TFRs are the most important, since Part 107 prohibits us from flying in a TFR. TFRs can be placed around open-air gatherings such as sporting events, air shows, disasters like forest fires, and move around with some VIPs. The quickest way to get NOTAMs for your mission area is to use the FNS NOTAM search site, linked in the description. To do so, first we need to identify one or more airports. We do this by going to a VFR sectional chart. What we're looking for here is the 3-letter ID for that airport. To learn more about VFR sectional charts, check out the series of videos linked in the description. If your work site is not near an airport, try to pick out 2 or 3 that will cover your work area. The 2 airports in this area are the Virginia Tech Montgomery Executive Airport in Blacksburg and the New River Valley Airport in Dublin. The IDs for these airports are KBCB and KPSK. The K indicates that the airport is located in the United States. Other nations will have their own letters. Now, we enter these 2 IDs separated by a comma to let the system know that we're asking for information about 2 different airports. After we submit this request, we get this table, which tells us if the NOTAM is active or closed, the airport it's been issued for, the NOTAM ID number, the type of NOTAM, the start and end dates and times, and a description of the NOTAM. If the end date is PERM, that NOTAM is permanent. It's also important to keep in mind that any times are listed in Zulu time, also known as Coordinated Universal Time, or UTC. This is a 24-hour format where the day starts with midnight at 0000 hours and ends at 1 minute to midnight, which we call 23:59 hours. Zulu time is always going to be the time at the 0 time zone, which covers England. We use this time format in aviation because it eliminates any confusion that might arise from using different time zones. Here, this NOTAM is telling us that this is a closed NOTAM, located at the Virginia Tech Airport. It's an airdrome NOTAM, which is an old-fashioned word for airport, and that it was issued at 1200 hours Zulu on the 10th of July, 2017. This is a permanent NOTAM, meaning that it will only end when another NOTAM is issued to countermand it. And lastly, this NOTAM is informing us that Taxiway Alpha is closed and no longer in use. Now, we need to read all NOTAMs. However, as UAS pilots, we need to especially focus on airspace NOTAMs. Most NOTAMs that you encounter will only affect manned aviation operations. In this case, we have an airspace NOTAM telling us that there's another UAS operation starting on the 10th of July, 2020 at 11:30 hours and ending on the 31st of July, 2020 at 23:30 hours. It's located at these geospatial coordinates, which is approximately 3.5 nautical miles southwest of the Virginia Tech Airport, and it's for a circular radius of 1.5 nautical miles from that point. Here we can see its location on the map in blue on skyvector.com. If there are any TFRs in the area that would prohibit us from flying, they would also show up under the airspace type. After I've read all of these and made special note of any that would affect my flight operations, I'm going to use my browser to print them as a PDF and save it to the folder where I'm keeping all of my project data in. This way I can reference them in the field if I need to, and now I've documented the fact that I've checked for NOTAMs. Now, let's move on to a simple way to get an official weather briefing. Under Part 107, this is required before each flight. This is because weather conditions will have a huge impact on the safety and efficiency of our flights. For a basic weather briefing, I want to use aviationweather.gov. From the default page, we will first go to Forecasts, then click on the link for GFA Tool. At the top, we have all the different maps we can look at, and there's a lot of information packed in. At the bottom of the map is the legend, with most of the commonly used symbology. If you see a symbol on the map that you don't recognize and it isn't on the legend, click here on the Weather Symbols link to see a full list. Now we want to zoom into the area we'll be working from. To start with, these points on the map are locations of airports. The color of each point indicates what category the conditions fall under. Right now, all of them are green, which indicates visual flight rule conditions. VFR conditions are what we're allowed to fly in under Part 107. If any of these points are red or purple, that would indicate instrument flight rules, or IFR, which we're not permitted to fly in. The point is also surrounded by basic information that we can read at a glance. The number to the left of the airport is the visibility in statute miles. The number to the right is the ceiling, or the lowest cloud layer that is reported as broken or overcast. This line coming out of the airport indicates the wind direction and speed. The line is pointed into the wind, and the tick marks at the end show us roughly how fast that wind is. Each half tick is 5 knots, and each full tick is 10 knots. Triangles are 50 knots, and red lines indicate gust speed. Where there is no wind at the airport, we will have a black circle around it. As an example, the wind barb in the legend shows us winds coming from the south-southwest at 25 knots, with gusts up to 30 knots. If we click on the Blacksburg Airport, it will give us a coded block of text that tells us the terminal area forecast, or TAF for short. The first line tells us that the forecast was issued on the 23rd day of the month at 1612 Zulu. This tells us that the forecast is valid from the 23rd day at 1600 to the 24th day of the month at 1200. Next, we have a block of text that shows us the current conditions at this airport. Currently there is no wind, visibility is greater than 6 statute miles, there's a layer of scattered clouds at 1,000 feet, and another layer of broken clouds at 12,000 feet. The rest of the text will be the forecast. Any line that starts with the letters FM is telling us that from this date and time, these conditions will be prevailing. Tempo means that there will be a brief change in conditions. So the forecast we have here is telling us that from 1700 hours today, wind will pick up to 6 knots, coming from 260 degrees. Visibility will still be 6 miles. There will be thunderstorms in the area with a broken cloud layer at 5,000 feet above ground level. Temporarily, from 1800 to 2000, visibility will be reduced to 2 miles, with light to moderate thunderstorms and rain, with an overcast layer at 4,000 feet. Then, from midnight on the 24th, there will be variable winds at 3 knots, 6 miles visibility, and a broken cloud layer at 7,000 feet. We can also see on the map large areas of significant weather called sigmets. These dark red areas are convective sigmets. This tells us that there are thunderstorms covering a large section of this region. If we want to see what the forecast would look like on the map, we can advance the map up to 15 hours by using this slider. The next map we want to look at is the cloud layer map. This will show us a grid with a symbol and text telling us what the clouds are like in that area. This is important because Part 107 requires us to stay at least 500 feet below clouds. Just like with the TAF map, we can look at what clouds are forecast to do up to 15 hours out. Now, let's take a look at the precipitation forecast. This is going to look very similar to a normal weather map, where green is rain, blue is snow, and purple is a mix. The darker the color, the more likely that precipitation is. These icons will also tell us other types of weather we need to expect. This map is telling us that most of the region can expect thunderstorms or nearby thunderstorms. And just like the other forecast maps, we can take this map out to 15 hours. Let's look at the wind forecast. This will show us the forecast for both surface winds and winds aloft. Surface winds are those your normal weather service will give you. However, this is often not enough. Wind will change speed and direction as altitude increases. Where these changes occur, there can be turbulence that can make flight unsafe. It's not uncommon for the first change of wind speed and direction to happen at treetop or building top level. So we want to check the winds aloft at the next highest altitude above ground elevation where we're going to be flying. We can do this by moving this slider. Since at lower levels it shows us the wind in increments of 3,000 feet, we will often have to do some interpolation to figure out the winds aloft at the exact altitude we'll be flying at. Now, let's check the weather by changing to the observation and warning maps. This will show us what the current conditions are. The symbology of this map will be the same as the forecast maps, but with the addition of a precipitation radar playing on repeat in the background. The time the radar map was published is listed here in the lower right-hand corner. We can see the rain is currently over our worksite and thunder cells are approaching. If we click on the New River Valley Airport, we can also see a decoded weather report called a METAR. This is the current weather conditions that are being reported by an automated weather station at that airport. There are also a number of apps available that you can use to get METARs while you're working. They don't pass for an official source for a briefing, but they are good for staying up to date on weather while in the field. This concludes our overview of a basic weather briefing using aviationweather.gov. Now, there's a lot more information that can be found on aviationweather.gov, and I encourage you to explore this site on your own. Also, the services that I've demonstrated are official sources of this information, and as such will count towards the legal requirement of a pre-flight briefing. However, you may have noticed that a lot of this information is rather coarse, especially when compared to the small areas most UAS operations cover. And this is why we also want to use some unofficial sources of weather information, such as Weather Underground or AccuWeather. While these do not fulfill my legal obligation to get a weather briefing, they do fill in some of the important information that is left out of the official sources. Having access to weather stations that are not associated with an airport can be incredibly helpful when your work site is 30 miles away from the nearest airport with a weather station. This covers your basic pre-flight briefing. Please join us in the next video, where we'll go over an advanced method for getting all of your briefing material in one place by using flight services. Thank you for joining us, and fly safe.